Hello my dear students, so welcome to the 8th lecture of the strength of material. So till now we have drawn SFD for various types of beams. So today we are going to see how to draw BMD, that is bending moment diagram. Okay, so I have taken a simply supported beam. So as I have told you in the shear force diagram that we will be drawing the shear force and bending moment diagram just aligning with the free body diagram, okay, of the structure which is given. So here it is the free body diagram of the simply supported beam. So I will not go to the detail how we will be calculating the reaction because it is already discussed in the shear force diagrams. Okay, so upon drawing this free body diagram, so we can draw the SFD. Okay, so SFD we have already drawn and it is already elaborated in the previous lectures. So now we will be calculating the bending moments at different points, and finally we will be drawing the bending moment diagram. Okay, so up to this much we have done, up to SFD we have done. So to calculate to draw the bending moment diagram, so we will have to calculate different values of the bending moment at different points. Okay, so to calculate the bending moment values, so we need to start from the left hand side of the beam towards the right hand side, because I have already told you that apart from the cantilever beam, for our other beams, so we need to start from the left hand side, okay, to calculate shear force as well as the bending moment. Okay, so at point A, so bending moment will be equals to 0, isn't it? Because what is bending moment? So bending moment is the summation of all the moments of the vertical forces, okay, of all up to a section. So up to this section A, okay, so before A there is no forces. Okay, so there is no force. That is why the moment of the forces will be 0. Okay, because no forces are there, so there will not be any moment. Okay, and for this force, so the perpendicular distance will be 0 at point A. That is why at point A the bending moment will be 0. Okay, then next point is point C. So at point C the bending moment will be how much? So there will be one upward force PB by L and distance is A. So force into distance will give you the bending moment. Okay, so one force is this one, so another force is this one. Okay, so for this force this distance is A. Okay, so PB by L, this is the force, sorry, this is the force PB by L multiplied by the distance. Okay, so small a is the distance, so it is clockwise effect. Okay, clockwise moment. So this force will try to rotate in this direction with respect to this point. Okay, so clockwise it is, that is why it is positive. Okay, so you, if you go through the sign convention, so it will be positive. So PAB by small l will be the bending moment at point C. Okay, and for point for force P, so it will be equals to 0, because for this line of action of this force, so perpendicular distance about this point is 0. So we will not be considering this force to calculate bending moment at point C. Okay, so only this force will be having one moment with respect to point C, that is PAB by L. Okay, now the distinct point is B. Okay, so we have calculated at A, calculated at C. Now we will be calculating at point B. Okay, so at point B, to calculate the bending moment, so we need to follow the definition again. Okay, so what is the bending moment definition? That at this section, okay, so summation of all the moments of the forces, so this is one force, this is another force, so summation of all the moments up to this section, okay, so is called the bending moment at that section. So for this section, so on all the leftward force you need to consider. Okay, so at point B, first moment will be PB by L into small l. Okay, so that will be the moment, force into distance, so PB by L multiplied by L. Okay, so this will be one moment, so it will be having, so this force will be having one positive effect. Okay, so clockwise direction, that is why it is written as positive. Then this is the downward force, so P multiplied by B, force multiplied by distance with respect to this point, so there will be another moment. Okay, so its effect will be anti-clockwise, that is why it is taken as negative. Okay, and this force is also acting but perpendicular distance for this force with respect to point B is 0. That is why we will not consider that force. Okay, means the moment of this force with respect to point B is equals to 0. That is why we need to consider the moment for these two forces. Okay, so which will be PB by L into L for this force and minus P into B. So here the effect will be anti-clockwise direction. That is why the negative sign is used. So L will get cancelled out. So PB minus PB will be equals to 0. Okay, so here by getting these three values, okay, so you can draw the bending moment diagram. So at point A, so here also the bending moment diagram will be composed of two axes. So one will be the span of the beam, that is the x-axis. Okay, you can take it as x-axis, and another will be the positive bending moment. So by capital M, bending moment is defined. Okay, bending moment is designated. So plus M, and here it is minus M, that is it is 0. Okay, 0 line. So from here we will be starting, because at A bending moment is 0, and we will draw straight inclined line. Okay, and it will cut this vertical line at this point. Okay, or at C it will be having one positive value PAB by L. So this is the positive value, and again it will be decreasing, and at point B so it will be 0. Okay, so one important thing you need to note, here it is written at the very corner, so I think you can see it. So if SFD between two points is a horizontal straight line, then BMD between those two points will be an inclined straight line. Okay, so SFD, see the SFD between two point loads. Okay, don't go for the UDLs. Okay, these concepts will be applied, this concept is applied for point loads. So here point loads are there in between point A and point C, the 2 point loads are there, and for these 2 point loads this is the horizontal straight line. So for horizontal straight line in the SFD, okay, so in BMD there will be one inclined straight line. So that thing you need to remember, and from this point to this point also here is an horizontal straight line. So here in the BMD there will be an inclined straight line. Okay, so this is also one peculiar characteristics of this BMD. Okay, so for SFD we have written the peculiar characteristics of the drawing SFD, and for BMD this is also one very important point. Okay, so thank you for watching this video. So after this video, so I will be giving you some assignments. Okay, thank you.